Good morning. My name is Kelly Johanna Barrera. I am a third semester industrial engineering student at UNAD Virtual University. Today I will present the results of exercise 4 from the physics course, which analyzes the motion of two cars moving along the z-axis. In this exercise, we studied the motion of car X and car Y using position and time data. The main objective was to determine the type of motion of each car, obtain their equations of motion, and find the point where both cars meet. First, we analyzed the data provided in the table and created graphs of position versus time. For this step we used several digital tools such as MATLAB, UA Simulator, and Educate+, which helped visualize the motion of the cars and verify the results obtained mathematically. Using MATLAB, we generated a graph where the horizontal axis represents time in seconds, and the vertical axis represents position in meters. In the same graph we plotted the motion of both cars in order to compare their trajectories. From the analysis of the data, we observed that car X follows a linear pattern, which means it has uniform rectilinear motion. This indicates that the velocity remains constant over time. The equation obtained from the linear regression was Zx t equals 4t minus 1. From this equation we determined that the initial position is -1 meter, the initial velocity is 4 meters per second, and the acceleration is 0. On the other hand, car Y follows a quadratic curve, which corresponds to uniformly accelerated motion. The equation obtained from the quadratic regression was Zt equals -2t squared plus 20t. From this equation we obtained an initial position of 0 meters, an initial velocity of 20 meters per second, and an acceleration of -4 meters per second squared. After obtaining the equations of motion, we calculated the meeting point of both cars. To do this, we equated the two position equations and solved the resulting quadratic equation. The result showed that both cars meet at approximately 8.06 seconds, at a position of about 31.24 meters. Then, we calculated the velocity of each car at the moment they meet. Car X maintains a constant velocity of 4 meters per second, while car Y has a velocity of approximately -12.24 meters per second, which indicates that it has already changed direction. Finally, the results were verified using the UNAD UA Simulator and Educate+, where the graphical representations allowed us to confirm the behavior of both types of motion and the point where the trajectories intersect. In conclusion, this exercise helped us understand the differences between uniform motion and uniformly accelerated motion, while also allowing us to apply mathematical analysis and digital simulation tools such as MATLAB, the UNAD Simulator, and Educate+ to visualize and validate the physical behavior of moving objects. Thank you for your attention.